Hey there, in this video, I'm going to walk through how to interpret the ANOVA results in Jamovi. So for this, here are the results for the ANOVA. If you don't know how to get to this point, you should go back and look at previous videos. But the first thing that we want to do is look at our omnibus test results, which is the overall test, which is this top part here. So we're going to look at the within subjects effects. And first, you can see here that this is the degrees of freedom and it's between the different time measurements, and it's the number of time measurements minus one. So there's three different conditions minus one. That's why the degrees of freedom between is two. And then this you can refer to it as the degrees of freedom within. It's more of an error term for a repeated measures ANOVA. And the way it's calculated is that you take the sample size minus one and multiply that by the number of time periods minus one. So in this case, our degrees of freedom is 35 minus one, and then times 3 minus 1. And so we get 68. The F value, the F statistic is 5.86. Our p-value for the overall model is 0.0045. And then our eta squared effect size is 0.11. So because this is statistically significant, because our p-value for the overall model is less than 0.05, we can now look at the post hoc tests. If it's not significant, you wouldn't even do post hoc tests. You would just say that the model is not significant. But because it is, we need to identify where the significant difference is. So the post hoc tests are below, and you can see that there's a pair. So the way this works is it's basically like conducting every possible t-test. The problem is that you shouldn't do that unless you're going to correct for the fact that each t-test you do to compare conditions or pairs of conditions, you're adding a possibility of a type 1 error. So you need to either correct for that there's various methods you can use. I use the Tukey post hoc comparison. So for this, here I have the comparison between silence and classical. So silence and classical. Because it's negative, what that indicates is that silence is lower than classical, which in our case for this example, we're looking at the time it takes to complete the Stroop task in different sound conditions. And so it's what it's saying is that the participants in the study completed the Stroop task faster in the silence condition than they did in the classical condition. And again, these are the same people. That's why it's a repeated measures ANOVA. And we know that it's statistically significant because we're looking for this p-value for the Tukey's test. So our p-value here, we could round to 0.01. And that is smaller than 0.05, so we're going to reject the null hypothesis here. Now, our other comparisons, this one is also silence, but it's comparing it to rock music. And you can see based on our p-value that we are not going to reject the null hypothesis there. So there's no significant difference between silence and rock, and there's no significant difference between classical and rock. So this is where it gets a little bit more complicated when you do an ANOVA or repeated measures ANOVA, is that you're also identifying the t statistic for each pair and the p-value for each pair, and then talking about that information. So the next video, I'm going to talk about how to write this out in APA style. And I will show how to create a table to represent these post hoc comparisons in the event that you want to make an APA style table.